Okay, so far we have seen pointers. We have seen pointers used with arrays. We have seen pointers used with functions. Now let's see pointers as well as arrays used with functions. So in main, I am defining an array of floating point numbers. So let's say that these are temperatures for a particular location, maybe on an hourly basis. And then I have defined another array for the fields like temperature. It has the same size as this original array, size 6. You can, by the way, calculate the size of an array or the number of elements in it using this technique. I calculate the size of the array, which is temperatures, and it'll be however many bytes you need for these six floating point numbers. And then I divide it by the size of any one of the elements inside it. So uh, you could use temperature 0 or temperatures 1. So pick any one of these elements and divide the size of the array by the size of one of those elements. And I'm using this data type size underscore t over here. You could use int as well. Size underscore t is an integral data type, but it's something that can never be negative, which is a safe data type to use whenever you're using um, indices for an array or sizes of an array. Then I'm making a function call on the next line, getMin, and I'm storing its return value in a variable named min. I'm passing the variable name temperatures and the variable name size to this function. So temperatures happens to be an array, and over here I'm passing that array to this function as the first argument, and the variable name size is the second argument. And remember that the name of an array is the same as a pointer to the first element in that array. So if you look at this function named getMin, I am handling it using an array syntax, which is fine. C++ allows you to treat an array's name as, you're passing an array. Uh, and it is done, by the way, by reference. So in this case, the array is not copied from the calling function to the called function. It's just its address is passed to the called function, and it can just iterate over it, whatever it needs to do. And I'm sure you're familiar with determining the minimum element from the array, which is exactly what we're doing, and then we're returning. And on the next line in main, I am calling another function, which is getMax. And you'll notice that the parameters are exactly the same as I used for getMin. But if you look at the getMax function, which is defined over here, its first argument is no longer an array. It is a pointer to a float. So like I said earlier, the name of the array is the same as a pointer to its first element, which happens to be a float. So I can treat this either as an array of floating point numbers or as a pointer to a floating point value. It's absolutely identical. So now, however, whenever you're dealing with pointers, I encourage you to make sure that its value is not null, because if it is null, then you might run into all sorts of nasty program crashes. Um, so if the pointer contains the value null, then we return immediately. So since the return type of this function is a float, so we have to return a float. So that's for that I have picked this value 0.0. Yeah, you could have picked a negative value or whatever makes sense as a temperature value that does not uh, occur in regular program operation. And then the rest of the program is figuring out the maximum value in this array, which is pretty much similar to the syntax over here, except instead of the less than sign, we have the greater than sign because we're trying to determine the max. And similarly, instead of saying temperatures I am saying star temperatures plus I. So if you recall, that pointer arithmetic basically skips over however many elements that your value of the variable I indicates. So if I is 1, you would skip from the first element of the array to the second element of the array. If the value of I is 2, you would skip over to the third element in the array, and so on and so forth. So this is the pointer dereferencing syntax. By the way, you could still use the array syntax over here and say temperatures I instead of star temperatures plus I around brackets. That is valid. C++ allows it as a matter of convenience. Yeah, so these two are equivalent. So this is how we may pass an array to a function as a pointer, and this is how we might process it. So let's go ahead and see what else we have in the main function. So once we've determined the minimum and the maximum, we display it on the screen, display those values on the screen. And then I'm calling this get feels like function, and I am passing it the temperatures array, and I'm also passing it the feels like array and their size, which is 6. So let's look at this feels like function, get feels like function. Well, it accepts both of these arrays as pointers, the temperatures array and the feels like. Now, since it has addresses of wherever those arrays are stored in main, this function can now make any modifications that it wants to the temperatures array or the feels like array. In this case, I want it to modify the values. Actually, the feels like array is initially, it's not initialized, so I want it to store valid values in there. And I'm just making up this fake formula for the feels like temperature. So let's assume that the feels like temperature right now is just, it's going to be 10 degrees above whatever the mercury based temperature is looks like. So I take the value of temperatures I, and I add 10 to it, and I store it in feels like I. So again, the same sort of pointer arithmetic. So this is one interesting use case where you want a function to be able to modify the values in an array. And on the next line in main, you uh, invoke the cout statement, and you say that here are the feels like temperatures, and then you call a display function and pass it the feels like array as well as the size. And here's the display function, which just goes ahead and it checks the value of the temperatures pointer, makes sure that it is not null. If it is null, it just returns immediately. Otherwise, it iterates over the array using pointer syntax and displays its values. So let's go ahead and see what happens if I try to run this program. Compile it, and then we run it, and it tells us that the maximum temperature in the array temperatures array was 35.2, the minimum was 32.5, and then the fields like temperatures are computed as 10 plus whatever was in the temperatures array.